All right, so a unit vector is simply a vector that has a magnitude of 1. Now, sometimes it's useful to have our vectors to be unit vectors, right, for various different applications, right, in different kind of areas of math. Right now, here we're going to start taking a look at two very, I guess, famous unit vectors, right? They show up in different applications. So here, and that would be the vector which is called I and J, right? Usually refer to them as just kind of I hat, and that's the vector that is strictly along the horizontal, right? In standard position 1, 0, and the vector J, which is along the vertical, and that can refer to as 0, 1. Right, so as you can see for both of these, right, the magnitude of J hat, right, we square root some of its components squared. So as you can see, that is 0. That's 1 squared. Root of 1 is 1. Magnitude of I hat, square root of 1 squared. 0 squared, which again is 1. All right. Okay, so as you can see, you could have taken the vector in the negative directions. Those would also be unit vectors, right? But I hat and J hat are these very specific ones that we'll see in a later video, how we use them to, I guess, simplify and have a more algebraic view of vector addition and subtraction and vector operations from there. Okay, now what we want to do here is we want to find a unit vector in the direction of a given vector. So here, let me write that down. So what I want to do here is I want to find a unit vector in the direction of V is 34. Okay, so here, if I just draw the vector here, so we have 1, 2, 3, 1, 2, 3, 4. Okay, so that's what our vector V looks like. Now, if we find the magnitude of V, we could see here equals 3 squared plus 4 squared. So that's 9 plus 16, which is 25. Root of 25 is 5. All right, so we see it as a magnitude of 5. Clearly not 1, clearly not a unit vector. All right, but what we're asked to find is find a unit vector that's in the direction of V. So as it turns out, the way to do that is if you define a vector W, and the way we define the vector W as V, and then divide it by the magnitude of V. This will always be always a unit vector. So you have, remember, the magnitude of V is just some scalar, and it's the number 5. Okay, so that will always be a unit vector. So now we know that we can define the unit vector W, and the direction of V will be V divided by 5. All right, and again, it's a scalar, so what we're doing is we're dividing each component by 5. So that is 3/5 and 4/5. right? So 3/5 and 4/5, it's like somewhere here, right? So it looks something like this, right? So here we have that vector W, which is a unit vector in the direction of V. So you can do this to any vector that you're given, right? That is not a unit vector, right? You can find the associated unit vector in that same direction by performing this operation, right? Finding the magnitude, then taking that magnitude and dividing each component of the vector by that magnitude. And the resulting vector would be a unit vector in the direction of V.